Hello everyone, in this lesson I will be discussing how to design a simplex lap winding for progressive and retrogressive. Before we proceed, let's learn the important parts of the design. We have the coils, the slots, these are the commutator segments, and the elements, or we also call it conductors. Now let's proceed to the given example. Now the parameters of the DC machine that I'm going to use are 12 slots and 4 poles. Now, normally, we could only get these two given, the slots and the poles. Now, for the other parameters, we have to compute all these things. Now, as to the number of conductors, we will go back to the diagram here. Now, for the simplex, there is always 2 elements per slot. So, if we have 12 slots, therefore, multiplied it by 2, we got 24 conductors. Now for the number of coils, there are 2 conductors in every coil. Therefore, we have 12 coils. And for simplex, the commutator segments will be equal to the number of coils. And since this is simplex, the multiplicity is 1. Okay, so since we already know these parameters, we can now plot the 3 parts of our diagram. So the first, we have slots. Okay, so slots 12, and then I got here 12 elements. 24 elements, 12 commutator segments, and as you notice, I added here another circle inside, and these are the representation of the poles. But in the actual, the poles are not located with inside of the commutator, so it's just a representation. Okay, so the poles is actually located in the stator of the DC machine. Alright, so next is we have to know how to design the coils. So there's the only parts of the design that is missing, which is the coils. Alright, so we needed to compute for the pitches, the pole pitch, back pitch, front pitch, and the commutator pitch. Now for the pole pitch, the formula is conductors divided by poles, so we get 6. Now for the back pitch, since this is progressive, back pitch is greater than the front pitch, so the back pitch and the front pitch must be both odd numbers. Now since back pitch is greater, therefore the back pitch is the higher odd number close to the pole pitch, which is 7. And then to get for the front pitch, you could just subtract 2 from the back pitch, and we get 5. And for the commutator pitch is equal to the multiplicity. If it is progressive, it is the positive m, or positive multiplicity. If it is retrogressive, it's negative multiplicity. Alright, so now the back pitch is the span of the connection. So we will be using the back pitch for the back connection. These numbers represent the elements. So when we say 1, that's the first element. And we have to add the 7 because that's their span, and it will be connected to the 8, the coil and 8. Now, taking the 8, starting from 8, we will now solve for the front connection, and we will be using the front pitch, or the span in the front connection, and that is 5. So we will subtract 5 from 8, and we got 3. Now how to plot this? Now every row of this table represents each coil. So let's start with the first coil. 1 to 8, 8 to 3. Okay, so 1 to 8, 1 going to 8. Okay, so let's connect the element 1 to any of these segments. Now 1 to 8, and it says here 8 to 3. So 8 to 3. But before we go to 3, we have to connect the elements first to the segments. So since we have here a commutator pitch, which is 1, it means there is only one span in the commutator. So 8 go to the commutator first before going to the element number 3. There you go. So that is our first coil. Alright, so let's try another one for the second coil. 3 connect to 10 and 10 to 5. Okay, 3 connect to 10. There. And then going back to the commutator segment. Then, where is it again? 10 to 5. So, to 5. Another one. Let's do 3 coils. 5 to 12, 12 to 7. 5 to 12. 5 to 12. Alright. Then to the commutator. And to 7. Oh, okay. So that's it. That's how you're going to design the progressive simplex lap winding. Then you will go through until the last coil. Okay, and it will give you like a flower design. Okay, next is for the retrogressive. There are only 2 differences between the progressive and retrogressive. Now for progressive, first is the back pitch will be less than the front pitch. Therefore, the front pitch would be the higher add number close to the pole pitch. Now we have back pitch of 5 and then front pitch of 7. And the commutator pitch must be the -1 or negative multiplicity. So how to do that? So I just do the same process in how to solve for the back connection and the front connection. I'll just change the back pitch into 5, which is 1 plus 5 is to 6, is equal to 6. 6 minus 7 is -1, but we don't have a -1 element. -1 is also the same with the 23, number 23. Okay, so let's start. 1 to 6, then 6 to 23. Okay. 1 to 6. 1 to 6. Alright, so let me choose here. For me, I want to choose these commutator segment. It will be depends on you on what commutator segments you want to put to. Now 6 to 23, right? Okay, so we have -1 multiplicity for our commutator pitch, so it means to the left with 1 span, and then go to element 23. Okay, so let's do another. That's our first coil. Our next coil is 23 to 4, then 4 to 21. 23 to 4. I'm sorry, doesn't look good. And to the commutator segment, again 2, I forgot, 4 to 21. 4 to 21. Okay, another one. Let's make 3. 21 to 2, then 2 to 19. 21 to 2. to the commutator segments to 19. Alright, so I hope you understand how to do the design. If you have any question, feel free to contact me, to message me. And that's it. Thank you so much, everybody. Have a nice day.